Okay, this is the last video in this section for using some word problems to show you how using the difference quotient can help you with derivatives. So this is a cool one because it says a calculus book is dropped from the top of a 100-meter high tower. Its height above the ground after t seconds is h of t is 100 minus 4.9 t squared. How fast is it falling 2 seconds after it's dropped? Okay, so if they said how fast, that is a rate of change. And the rate of change is, as you well know, we've been practicing it, your rate of change is a derivative. And it's basically the slope. So if you think about that, how fast, you want to know the speed that it's falling. Not how high it is, but the speed. So I'm going to do a little picture here so we can see what we're really looking at. So life is in quadrant 1. So here's time and here's the height. And they said it's 100 feet, so this is in feet. So here's 100 and this is in seconds. So basically this book is dropped from 100 feet and it's going to hit the ground at a certain time. And what this question is asking is how fast is it falling at 2 seconds? So we'll say 2 seconds is here. They basically want to know not how high it is, but how fast it's falling. So you're kind of looking for the slope of that line at that point. So you're looking for the slope or the rate of change is what you're looking at. So that's my little attempt at a mini tangent line there. So let's go through and do this. So I've got to do the derivative. So I know that the derivative is f prime of, and we're going to find it at 2 seconds, equals the limit as h approaches 0, that's an m, h approaches 0 of, now we got to put the 2 in there in our formula, so it's going to be 100 minus 4.9, okay, and then here we're going to put our 2 plus h squared minus, then we're going to do f of 2 or h of 2 in that spot, so that's going to be the same as saying 100 minus 4.92 squared all over h. And if you need a little refresher, remember that f prime of a is going to be f is the limit, the limit as h approaches 0 of f of 2 a plus h, in this case it's 2, minus f of a all over h. So that's just a little refresher, and that's where this came from. I put the 2 plus h in that spot. Okay, so now let's continue on, and basically from here on it's algebra. So I've got f prime of 2 is the limit as h approaches 2, 0, I've got 2 on the brain, 0, of, and then we're just going to do some algebra. So I got 100 minus 4.9, and then I've got 2 plus h squared, so that's 4 plus 4h plus h squared. And then it switches all this, and basically this all comes out to be 80.4 if you put it in your calculator, so it's minus 80.4 all over h. So I have f prime of 2 is the limit as h approaches 0 of 100 minus, and then we do the distributive property, 19.6 minus 19.6. Let's try that again. 19.6 minus 19.6 h minus 4.9 h squared minus 80.4 all over h. And again, I told you that if you're done right, it should cancel out. And if you were to look at this, the 100 minus the 19.6 minus the 80.4 makes it disappear. So that's nice. So I say thanks for playing, because they kind of cancel each other out. So I have f prime of 2 is the limit as h approaches 0 of negative 19.6 h minus 4.9 h squared all over h. And again, we can factor out the h on top, because I still cannot put the 0 in there because I'll get 0 over 0. So let's see how much room I have down here. I can do f prime of 2 is the limit as h approaches 0. And I'm going to factor the h out, so I have negative 19.6 minus 4.9h all over h. Now these can cancel for 1, equals the limit as h approaches 0 of negative 19.6 minus 4.9h. Now I can plug in the 0, so I have f prime of 2 equals negative 19.6. And I got rid of, if you've noticed, the limit because I'm actually plugging the 0 in, equals negative 19.6. Now, the units are what I want to talk about because, and I actually think I misread this. It's in meters, not feet, so I want to apologize for that. Let's change this. Because if you're talking slope, you're looking at something per something, a rate, okay? So this is going to be in meters per second because it's the slope, it's a rate, so you're comparing two units. So that's important to me that you notice that your units when you're talking about a rate or your derivative is going to be different than if you just did the equation. Okay? Now the other thing I always get a question is, why is this negative? Well, because the book, remember, if those of you that are taking physics, velocity is a vector quantity, and that's really what you're talking about when you're doing meters per second. And the negative shows that it's in the downward direction because the book is heading down towards the earth, the ground. So that's why it's negative. It just shows your direction. But the units or the speed of that would be 19.6 meters per second. Okay? All right. We have one last one here, and this one circles changing area. And it says, what is the rate of change? Again, I underline that. That's a derivative. It's slope. It's and so now you know it's the same units that we did before. Okay, of the area of a circle with respect to the radius when r is 3. Okay. Well, I have a formula here. I have a equals pi r squared. So I'm going to write this down. All right. Now you got to remember when you have a formula here, this is a variable. The r is a variable. So this is area and this is the radius. Okay. The pi is a constant. So it looks like there's 3, but there's only 2 variables there. Okay. And they told us when the radius was 3. Right. So I know that f prime of a is the limit as h approaches 0 of f of a plus h minus f of a all over h. Now the only problem is this was written with an a equals. You could actually say this is f of r if you need to because the area is a function of the radius. But they had it this way, so that's all right. So we're going to find when the radius is 3. So we're going to be f prime of 3. So we got is the limit as h approaches 0 of, now here's your formula right here, so we're going to put it in there. So it's going to be pi times 3 plus h squared minus pi times 3 squared, because that's what the radius is at that time, all over h. All right. So when I go through and do some algebra here, got f prime of 3 equals the limit as h approaches 0 of pi times 9 plus 6h plus h squared. You should be getting better at doing your double distribution, and that's 9 pi right there all over h. Let's continue down. F prime of 3 is the limit as h approaches 0 of 9 pi plus 6 pi h plus pi, that's a plus, pi h squared minus 9 pi all over h. And again, you'll notice how this is canceling out, which happens every time. Thanks for playing. So I end up getting a f prime of 3 is the limit as h approaches 0 of 6 pi h plus pi h squared all over h. Now we cannot, we still can't plug our 0 in, so we've got to continue on with this and factor out the h on the numerator. This should be getting used to this. 6 pi, sorry, I lost my track of thought right there, train of thought, 6 pi plus pi h all over h, thanks for playing, equals the limit as h approaches 0 of 6 pi plus pi h. Now we can put a 0 here for that, so we end up getting f prime of 3 actually comes out to be 6 pi. Now on this one, they didn't really tell us the units, but it would be something per something, but we're going to leave it as just 6 pi because that's all they gave us. So I hope that helps, and we'll be talking about this more in class.